first, and now there are many cases that the farmers and truck robots perform their own tasks in the same field. They are working avoidantly interact with each other and limit the risk of collisions. Therefore, unstable avoidance system is necessary and important part in robot application. And with the development of the agriculture, autonomous robots are being increasingly used instead of the conventional tractors. So it is also a system that helps it to detect the obstacle. And now I will talk about the material and the methods. And below is the card and equipped with the PC and IMU and GPS and the 3D camera. And what is the important about this system? Well, I think it's the 3D camera. You need to, the system is to avoid the obstacle. So what you need to do first is you need to have an identification of what is the obstacle or what is not or what is background. So you need to have a 3D camera that can show you. And this is a picture about a 3D camera that it takes. You can see the first, it was two person standing here, and then the 3D camera will have a range image, and then the noise image and the background is that we don't need, so we need to remove that. You can see the third picture that the noise and background has been removed. And then we have a filter to a number 4, and you can see that the number 4 picture, it has a clear 2 people left in the picture, so that is the obstacle. And this is a diagram that about the system. You can see that there is a car from the A position to the B position, and on the left there is an obstacle. And when the car goes there, and the 3D camera will detect it, and it will let the car to be slowed down or stop. And then it's the result and the execution. This is the position accuracy. We see that in the right hand side, the dark is the position of the obstacle, and the 9 is the position of the obstacle led by the 3D camera. And the paper says that the distance between the two is very approach. The maximum error of only 10 centimeters. And then there is a picture about 2 lines. The A9 is the distance between the car position and the start position. The B is about the obstacle. So you can see the first that if the obstacle is stopped, and then the car starts from the start position, and when the car approaching, the 3D camera will detect the obstacle, and when going to the same range, it will let the car to slow down or stop. And when only if the obstacle move away or run out, and then the car will start to continue to move. And this is same as the next picture. Now you can see that there is the obstacle distance by a 3D camera. With that, at the beginning, the two things has very far, and when it comes to the safe range, and the PC PMC will let the car to slow down or stop when the when the two things are bumped, and the car will beginning to run. And now is my conclusion. This study has developed a system that can provide a precision accuracy. Just like the letter what I said before, I said the system has the maximum error of 10 centimeters. And field tests indicate that the obstacle could be preventively detected, and the robot will slow down or start to avoid the obstacle. Thank you for your listening.
Are there any questions? Please. And your conclusion? They say the science system has a maximum error of 10 centimeters. Is that bigger or that's okay? That's error. What? The error is okay. The number okay. Is okay. Yeah. Okay, thank you.
Thank you for the presentation. Can you go and show the slide materials and methods? Where there is the range image after this. Just after this.
After this,
And how can you remove the noise and the background in the range image?
and this paper didn't very mention that, but I think it is used maybe a filter, like the medium filter or a range filter. I guess I didn't really mention about that.
Okay, thank you.
Thank you for your presentation. Can I ask a question about the limitation of the range image? Can this system, is the moving speed of the obstacle will limit this system's performance?
You say
If the obstacle moves too fast, is this system can work still well?
move to that, and I think you have a speed limit. If the move too fast, and it can catch the range image. But I didn't know the limit is what is the speed.
Okay, thank you.
Any questions from Japan?
Thank you for your presentation. Please show me the materials and methods slide. Yes, this slide. I don't know the system of IMU and PMZ. Please.
You say IMU?
Yeah.
Oh, IMU is the interior measurement unit. It can measure your speed or acceleration. And PMD is a 3D camera that can take a picture and a range image.
Okay. Thank you very much.